last case was when actually the object is beyond 2f. I'll show you which case was I'm talking about. I'm talking about this case. What are the characteristics of that case? When object is beyond 2f, the image form within f and 2f, and size of the image is smaller. And if you see that here the arrowhead is at the top, here the arrowhead is at the bottom, right? So arrowhead top, arrowhead bottom, right? So arrowhead top, arrowhead bottom means image is real and inverted. Okay. Guys, any practical application for this thing which you ever see in your life in some object? The practical application for this case is micro, where the size of the object is big, but when you print it out, it becomes a smaller in size. Or there is another thing which you can see, camera. Camera uses this case where object is beyond 2f and image is within f and 2f. You see a big scene or something and the image comes within f and 2f. So best example is camera. Now second example is this one, where you place object at f, where you place an object at 2f. So when you place object at 2f, this is focus, this is focus, this is 2f, this is f, and this is 2f as well. What if I place my object here? Again, same way, object which is parallel to the principal axis after refraction passing from the focus. An object which is passing through the center of a mirror lens will not change its path and it will cut at this point. If you see that object is now placed at 2f. When object is placed at 2f, image is formed at 2f as well. Size of the image is same as the size of the object. As the object. Image is real and inverted. So basically what you are doing, you are bringing the object closer to the lens and seeing what type of image you are forming. Previously, object was at the back, image is smaller, and it was between f and 2f. Then you bring the object at 2f, the image form will be at 2f. By the way, what is the practical case of this scenario? What is the practical case? Yes, guys, practical case. Which equipment or which device uses this case?
Projector.
Projector gives you a big image. Any particular object or optical instrument which gives you the same object size as the image size or same image size as the object size. Photocopier. Basically what happened, when you place your object like book whom you want to print, you will set the lens of the printer in such a way that you are exactly double of focus from the lens. Your book will be double of the focus from the lens. So in this way, you will find an object at 2f. It will be like this. Let me show you. Wait, this one. No, not this one. Sorry. This one I'm talking about. This is the image I'm talking about. Now, guys, one more thing. If I bring the object further close to lens, actually, what do you expect? The size of the image will be bigger or smaller if you are bringing the object further close to the lens? Yes, any guess?
It will be smaller.
No, if you're bringing the object nearer to
Closer,
the,
right?
it will be bigger.
Sir, how?
If you're bringing the object nearer to the lens continuously, the lens will make a bigger image of this. If the
Sir, but like if you bring the object nearer, the space will get smaller, so it'll have less place to project.
no, 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 no. See, if the object is very far and you're watching it from the camera, what happened? You will find an image.
Is big.
No, it's not big as the object size. It may be big, but not as big as the object size because you are watching it from very far. But if you yourself go with a camera and try to take the object, it will look bigger and bigger and bigger. And if you're very close to that, it will be so much big that it is bigger than the object size. I'm not talking about the image is bigger or not. I'm saying if you compare the image size with the object size, will that be bigger or smaller as compared to the object? For example, you're taking a picture of a sun, right? You're standing very far. My point is your image may be very big, but is it as big as the sun? Ibrahim, that's what my point is. When you are going closer to the object, I mean your what do you call it, lens, the image size will be bigger and bigger and bigger. So what happened next case will be that your object will be placed within 2f and f. Where will the object go? Any guesses? When it was beyond f and 2f, the image formed between f and 2f. When the object will be within f and 2f, where will the object be going? Beyond 2f. So for that reason, let's put this now this way. This is your line. This is your length. This is your f. Here you got an f. Here you got 2f. There you got 2f as well. This distance, if 1, the distance between f and 2f will also be 1. If your object is here, same thing, line which is parallel to the principal axis after refraction passing through the focus, and a line which is passing through the center will go like this. So here, object position will be what? Between f and 2f, and image position is beyond 2f. And what is the size of the image? Yes, Ibrahim. What is the size of an image? Any guesses?
It's larger.
It's very large or large, in large. And because image is inverted, so you can say real and inverted, right? Now, what is the practical application for this particular case in our real life? Anyone has any guesses? Practical application where the image size is greater than the object size. Yumna, Armina, anyone?
Sir, when you're taking pictures from a camera,
But camera already
um,
seen, or camera was beyond 2f.
oh, okay.
So what other thing? Projector. Projector is this case actually. Projector uses this case. Those projector which are actually in our schools, they use this case. Now my one question is, projector image is actually inverted, but how will you see that image as erect image? If you see that projector fixed in the wall, they are in the inverse direction. If you see that, they are fixed in a wrong way, or you can say in a opposite direction, upside down. That's why the reverse image is seen straight image to you. Actually, the image formed by the projector is reversed, or you can say upside down, inverted. Anyone have any question? Please ask. This is a bit tricky topic, but we have to finish this.
No,
Army,
sir.
Yumna, you?
No.
Ibrahim, what will be the next case? Where shall I put the object now? Asad, you? Where shall I put the object now? It's in between F and 2F. Now, where should the object be? Next case.
After F.
At F. Now, it will be at F. So, let's do it. Now, this will be a strange case. You will see yourself. Object, again, this is your lens. That distance and that distance from the lens is same. Then you will have 2F, F2F, sorry, F, 2F here. Now, image is right at F. Image which of line which is parallel to principal axis after passing will pass from the focus. A line which is passing through the center will not change its path. This is what happened. What is happening now? What shall I do? Lines are not cutting each other. So what to do? Lines are not cutting. They are becoming parallel to each other. If I extend these lines, even then they are not cutting. So first thing first, object position at F, image position. Image position is, yes, what is image position now?
Sir, there is no image position.
No, there will be an image because mathematically we believe that two parallel lines will meet after some time. They meet at some point. Mathematically, a thing which is not achieved, what do we call it in mathematics? A point which is out of range is called what point? Anyone have any ideas? In maths, when something is out of the range, what do we call it? It's called infinity. So image will be formed at infinity. So we do believe that image will be formed, but at infinity, very far away. So we believe definitely if infinity image is formed, then the image is inverted and real. And second thing is if it's formed there, it will be very big image because we see already that if image is formed far, image will be big. So it will be enlarged, real and inverted. Now, which particular device use this particular case? Any device that comes in your mind? Anyone? Any device which uses this case? Spotlight. You know that light which is used in the big halls, in the big shows, where that light will be spotting only the person who is only the person who is performing, and all the hall is in black. That is your spotlight. Spotlight only and only focusing on the person who's performing. So that spotlight is basically used that particular case for its performance, for its operation. Okay. Now, what will be the next case? Yes. Anyone have any question?
No, sir.
No.
Ibrahim, you Ashad, you?
No.
Okay,
No.
now the last case. Now object will be further close to, so this is your F, this is your 2F, this is your F, this is your 2F. Now image is between F and 2F, between F and optical center. Now see what happened. Passes to the lens after refraction. Focus it will pass. It will pass from the center, but it will not meet, but rather they are going apart from each other. Now what to do? Shall we proceed them further? Because they are actually going apart. If you are further drawing these lines, they are actually going apart. So what we do in this case, we proceed these lines in the same direction, behind. And when we proceed them behind, it look like they are coming from one point. Where they come from, they look like coming from the point, we believe that's where the image is formed. Now, if you see that the arrows of both the images are at the top, it means that this is not the real image because this is not formed by the real light intersection. But second important thing, it is formed on the same side of the lens where the object is. So, first thing is object position. What is object position? Between F and optical center. Where the image is formed. Anyone? Image position? Yes. What is the image
Sir,
position?
behind 2F,
No, no.
before
We
2F.
see. We don't say it is behind 2F. It can be anywhere because this image is not actually formed by the real intersection. We proceeded it backward and then it is formed. It can be at 2F. It can be at F. It can be very far. Important is not this. This is at the same side of the image. This is important. You can form this image anywhere but on the same side because wherever these lines are meet, this image will be formed at the same side of the object. Now, image, how does it look like? Is it a real and inverted image? Ibrahim, is it real, inverted? Hello? Anyone?
Um,
Is it a real image or inverted image?
no.
Then this image is virtual and erect. And the most important part is it's a very big image. So we called it magnified image. And the practical application of this case is magnifying glass. This was the last case of this lens making, I mean, this image making through the convex lens. Anyone have any question related to that? Please ask. I'm just showing you this image here. See through these and ask me if you have any problem. Don't see this one. There is no need for that. Other than that, see the cases. One, two, three, four, five. There are total 5 cases altogether. Check it out and tell me if there is any problem. I will explain it again. But first of all, go through all the cases. One case is at F when the object is placed at F. One case is when the object is placed between F and optical center. One case is when object is placed between F and 2F. One is beyond 2F. and one is at F. When object is placed beyond 2F, image will be formed between F and 2F. In that case, the image size will be smaller in size as compared to object size. Then image in this case will be real and inverted. Next case is when the object is at 2F, this one, object is placed at 2F, image will be formed at 2F, which is real and inverted. And the image will be of the same size as the object. Next. Next is when object is placed between 2F and F, the image will be formed beyond 2F. The image again will be real and inverted, and it is larger in size as the object size. The next case was when object is placed at F, the image will be formed at infinity because the lines after refraction will be parallel. This one. And in that case, we believe that object size is very large or enlarged, you can say, but will be real and inverted. And the last case is when object is placed within focal length, or you can say between F and optical center, the image will be formed at the same side of the lens where the object is. And this will be enlarged or magnified, and it will be virtual and erect. Each case, there are application. For case number 1, the application is camera. For 2, the application is photocopier. The third case, you have a application projector. For fourth case, you have a application spotlight. And the last case, it's magnifying glass. Anyone have any question? Please ask. I'll give you 5 minutes to see through, please. Okay, guys, now let's have a quick small quiz related to what we have studied in this chapter till now. Quickly, anyone, I will take the name and you have to tell me one difference between a convex lens and a concave lens. One first difference. Who will tell me? Quick.
So the convex lens is thick from the center and thin from the edge, and the concave lens is just narrow.
You can say thick from the edges and thin from the center. Absolutely right. This is for the construction. As far as the image formation is concerned, who make most of the images at real and inverted, and who make virtual and erect image? Armina, any clue for this?
Sir, convex lenses makes a real image and concave lens makes virtual images.
Absolutely right. Except one case, convex is making all the image as real, except in the last case we already discussed, right?
Yes, sir.
But in concave, there are all images are formed virtual image, and the size of that image will always be smaller. In convex, there will be different images, right? All right. Now, another thing. Who will tell me the difference between real and the virtual image? First difference.
The real image is inverted always.
Always inverted. While what about virtual
And
image?
the virtual image is erected.
Or active. Ibrahim, second difference. Yumna,
Real image can be shown on a screen, and virtual image, like it can't be shown on a screen.
it means that image from the magnifying glass can never be shown on the screen. Am I right?
Yes.
So, what else? There is another difference which I told you.
Uh, Virtual images are erect.
That's fine. He told us. Real images are formed by the actual intersection of the light rays, while virtual image is formed by the virtual intersection. Means lines are not actually intersecting each other, but when you proceeded back at the same side where object is, they look like coming from the one point. So, real image is formed by the real intersection, while virtual image is formed by the virtual intersection of the light. rays. All right. So this is the difference between the real and the virtual image. Now, quickly, one small topic which actually missed. So let's quickly do that here. Mirror. Now, one point. Image is formed by the plane mirror as well. I'm talking about plane mirror. First of all, image formed by the mirror. What is the nature of the mirror? Mirror image, plane mirror image. Will that be real, inverted, or erect and virtual? Yes, guys. Image formed by the plane mirror.
It will be virtual.
It will be erect and virtual, definitely. So now put a heading, image formed by the plane mirror. Characteristics. Everyone has a plane mirror in his house, in her house as well. My point is, what is the characteristic of the image formed by the plane mirror? Quickly. First characteristic. When you see you in the mirror, what do you see? How do you say that this is mirror and this is the image? What are the characteristic of the images?
The image is erect.
That's the first thing. Image is erect. And one more thing. It's flipped as well. Flip means your left hand will be the image right hand and your right hand will be image left hand. One more word is used here, upright. Upright means straight. So another word for the erect is upright. What else? Other characteristics. What about the size of the image? Yumna. The size of the image which you see in your mirror is as compared to object is what? Greater, smaller, or equal?
Equal.
Equal. So you can say that image size is same as the object size. What about distance of the object from the mirror and image distance from the mirror? Distance of object and image from the mirror will be same. Both got the same distances from the mirror. So three qualities, erect, flip, upright, and image size is same as the object size. And the second last is distance of object from the mirror is equal to the image distance from the mirror. This is for the mirror. Now, one more thing, which is actually we are talking about magnification. Especially when you're talking about the lens, you're talking about the magnification. Now, what is magnification? It's a ratio between image distance and object distance, or image height and object height. In other words, you can say M is equal to image height over object height, or you can say image distance over object distance from the mirror. So this is your magnification, another term which is used in so much. How big your image will form by the lens, that will help you. Maybe you heard of it that your mobile lens is 2x, 3x. It means the image height it will provide you is 3 times the height of the object or 2 times the height of the object. Ibrahim, what is the unit of magnification?
I'm not sure.
There is no unit for magnification because it's a ratio between the same quantity. We just denote it by a number. That's it. There is no ratio. I mean, there is no unit for magnification. So no ratio. I mean, this it's a ratio. So we called it just a number. This is just a number. Okay. So technically speaking, this is our topic actually. This was our topic related to the lens and image formation and magnification, and all the things are actually covered in this. If you got any question for me, please ask, because once this chapter will finish and another chapter, let's do that, we will do that. We will jump to the past paper questions related to that. Now you tell me, after finishing this chapter in the next class, which chapter you want me to start with? All of you. Just if you agree on something, then let me know. What, Ashit?
Sir, space physics.
Electromagnetism.
Magnetism? Yes,
Yes, electromagnetism.
magnetism, electromagnetism. Okay, no problem. So in the next class, we will come with, I mean, we will start with electromagnetism because this chapter is going to be finished here, right? So I want you to go through this. If you find anything, please bring it on. And if you have missed anything, just let me know. Okay?
Sir, when will you do space physics?
Space physics. Okay. Once we finish with some topics, we will come with the space physics because it's a pure theoretical topic. Even before your examination, if we have time, we will finish it. But before that, we have to finish the major topics, that is electromagnetism and magnetism. Then we have waves and sound. Did we finish wave and sound?
No, sir.
Then we have a wave and sound. And once we finish with all this, we have kinematics, work power energy, and all this. And once we end up with all this, we come to uh, what do you call it? Space physics. Okay. But
Okay.
we will do first magnetism and electromagnetism, and right after that we have another chapter, radioactivity, which is very small chapter. So we will finish that, and then we jump to waves and sound, and then basic, that classic physics. But between that, I am thinking of taking a test as well. What do you say? Are you ready? If I ask you to take a test? Yes, fellas. Ibrahim?
Yes.
Okay. Not in this month, in next month, maybe after Ramadan. Okay. I will let you know. So what we do, we will finish our class here, and I want you to go through this chapter because this chapter ended here, and that's all. One more thing here, magnification of a convex lens is taken as positive, and magnification of concave lens is taken as negative. Can anybody tell me what's the reason for this? The reason is very simple, because image formed by the concave is not real, and because it's not real, then we will take image distance as negative, so we take magnification as negative as well. So magnification of a convex lens is taken as positive, while magnification of concave lens is taken as negative.
Sir, can you explain magnification again?
Magnification is the ratio between image height and object height. Like, for example, if I say your object height is 2 and your image formation is 4, what is the ratio? 4 divided by 2. So this 2 tells you that this lens has a capability or ability to enlarge your image by 2 times. Same thing if your image size is, let's suppose, 6 and your object size is 2, and when you divide these two, you will get 3. It means that this lens has the ability to enlarge your image by 3 times. So this 2 will tell you how big your image can be by using that particular lens. Okay, Ibrahim?
Yes, sir.
Okay, then we'll finish our lesson here. In the next lesson, we will start with electromagnetism, magnetism. Okay, if you have any question, please bring it on, because once the electromagnetic chapter will finish, we will do some of the past paper questions. Okay, from electricity, electromagnetism, and light, and then we will inshallah go for other chapters. And inshallah, as soon as the Ramadan finish, we will take a test as well. So get ready for the test soon. Okay. See you guys. Take care of yourself.
Okay.
Allah Hafiz. Yes.
Long